And as requested, all of you, please be ready with your laptop in order to have the hands-on session effectively. Thank you. Please, ma'am, you can continue.
Yeah, thank you, Saranya ma'am. So hope you are all connected back for the session 4. Okay, we have got 2 more sessions tomorrow, and as you know, we are working with the text data set. Tomorrow we'll be working with the image data sets, right? So image data sets, right? How far we have completed? Can one of you recap what did we analyze, or what did we demonstrate, or what did we have a hands-on session in the 4-month session? Hands-ons. What are the new packages or new thing that you learned on the 4-month session? Yes, please. Can one of you unmute and speak? Or also you can put it onto the chat. Hello. What are the new functionalities or new things that we have learned during the 4-month session? You are able to hear me? Yes? Okay. Are you able to hear me or not?
Yes, ma'am.
Yeah. Yes, what are the things that we have seen in the 4-month session? Can one of you unmute and speak? We started with can you step? What are the we have fetched a problem? What is the problem that we have defined? What was the problem that we have defined? What was the objective that we have defined? Can one of you say? We were discussing about what predictive model? You're trying to predict? Hello, you're all connected. Anybody can answer. Can you give me a response, please? But what data set we have been analyzing from yesterday? Anyone? We're discussing about what data sets?
Ma'am, medical data set, the
Yeah.
kidney data set, that one, or in the
Yeah, kidney data set. We were discussing about kidney data set from yesterday. Yeah, kidney data set. Thank you, Karthikeyan sir. So we defined a problem. If you're not speaking, you can put your mics on mute. We've defined the problem to develop a predictive model. So what happens after the training and testing, after we develop the model, when a new patient comes, as we feed in the data onto a system, okay, as we feed in the data onto a system, my system will be able, with the learning, with the data patterns that are trained, for the new app, for the new patient, it will try to say whether this particular patient has got a kidney disease or not. Okay, so that is what we are developing a model. So from that model, we are training along with the learning data sets. The more data sets, the more good prediction will be your algorithm. Right, so we have taken a data set and we have done the exploratory data analysis. What are the packages we have seen? We worked with NumPy, Sky, Matplotlib, Pandas, Plotly. Yes. Did we work with missing values? Did we see the visualization of missing values? Yes, no? Answers on chat.
Recording in progress.
Okay.
Yes, ma'am, we have worked with missing values as well.
What are the 3 types?
We have used grade also.
Yeah.
Grade.
Visualization, bar graph, then the matrices, and then we moved on to a heat maps, right?
Static grade.
Yeah. And then now we are in the process of converting and if there is missing values, there is a lot of optimization algorithms where we can work with missing values on different imputations. But here we have not worked with imputations, but rather what did we do? We have dropped the rows that contained any null values, right? Because that will take even one more deeper work onto that, so that I'm not touching into it. If you want to learn more, it's like we provide like 40 hours course, 80 hours course from developing, right? And you train some research scholars also, they are with in my campus, in my company. So what do? They come with the problem definition, we train them, and they develop. You will be developing it, right? So that course will be telling, because each of you need to do your own methodology or your own research contribution, so that you can think of focusing of different ways to handle the missing values. And then you can think of the feature engineering. Say for example, if your data set is going to have 74 columns or 80 columns, how far you're going to take those data sets, and how far you're going to use it, right? What optimization algorithm could be used to select the necessary features which has got the high correlation, to work on with that. All right. So where did we leave? Forenoon session. It's very difficult if you don't respond properly back, right? Kindly do respond. Where did we leave in the morning session? We are in the process of
df1.df
yeah,
drop name function.
we have dropped down, and then now because the missing values we have dropped, and the 400 columns rows have become to 153. Okay, 150 sorry, 158 rows. And then we have seen there is no missing values in df1, and now we are in the next process of label encoding. So I told you, right, two things are very important when you want to develop a machine learning algorithm. It should not have categorical values, which means you should not have like strings, right? And you need to convert it, so wherein we will be using a label encoder. Say for example, if your data set is going to have a traffic signals, right? What are the three colors in traffic signals? What are the three colors in traffic signals? Hello? Traffic signals, what are the three colors we have?
Red, green, yellow.
Yeah. So you have generally, if your one of the column is going to have a traffic signal, which is going to have red, yellow, and green. Okay, you can map it on. Okay, when it is very small, then you can map it on to what numbers you wish. You remember we mapped using dot map function. Remember where did we use dot map function? You remember we used map function? CKD to
Yes, ma'am.
0 and non-CKD to 1, wherein we used a map function. Okay, say for example, if your column is going to have so many number of unique values, okay, that is an object type, or if it is an integer, then you want to work it on with that, then what do? We need to change those values. So it's very difficult for you to think and change. Okay, think and change. So here, if it is very small, then you can use this function called map function. Okay, we can use this function map. Can you see? Like dot map of df dot class, that column name dot map, wherever it is CKD, I'm mapping to 0, non-CKD, I'm mapping it to 1. All right, but it will not be the case if you have more number. So you have something called it will be mapped automatically to 0, 1, and then 2. Say for example, in your column you have got so many, right? Then you go on something called as label encoder. You go in a concept of label encoder, which resides in SkyKit package of its pre-processing technique. All right, of its pre-processing technique. It is available over there. So what do? It has a package. We need to create, we have to import that functionality and instantiate, and we need to instantiate. And how many of our columns, how many categorical columns we have? Do you remember the morning session I told? How many categorical columns you have? Can one of you say how many numerical columns, how many categorical columns? There are numerical columns and 14 categorical columns, right? nominal columns, and where you have how many?
25.
Yeah, how many?
25 columns.
Totally you have 25 columns, out of which how many columns you have? See objects, can you see? Red blood cells, first cell clumps, and bacteria. Okay, is bacteria present or not? Can you see on my screen? Is my screen visible where I'm highlighting? Yes, you're able to see my screen. If so, type Y on the chat, or if you're not able to see my notebook, type N on the chat, please. Yes, I don't know whether you're able to hear me or not. You're able to see my screen? Hello?
Yes, ma'am, it's visible, but for some, it I think is not visible.
Okay. Okay, it's visible. Is my voice not proper?
Couldn't able to hear you properly, ma'am. Can you repeat it?
Okay. So, out of these columns, all the others are integer values. And how many columns you have that are categorical values? How many categorical values you have? Categorical means the columns that has strings, the column that has strings. Okay.
14 numeric values. That means rest will be the object.
Yeah, we have 25, right? And once it is all integer values, we go in for correlation. Other than these columns, the remaining columns will be okay. Even for heat maps, it comes only for columns which is are numerical numbers. And these are the things we have seen in the morning session. You remember using plotly, the violin plot, the scatter plot, the bar plots, and it's interactive. All right. And then we used for relationship only one example we took on facet grid. Okay. And now before moving on to that, what is the type? How many categorical columns? So red blood cells have two categories: first cell clumps, bacteria, hypertension, diabetes mellitus, coronary artery disease, yes or no, hepatitis, yes or no, okay, anemia, and classes two categories. So how many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So all these 11 columns I need to convert it into, from categorical I need to convert it into what? Can you tell me?
Numeric.
Numerical value. In order to convert that to numerical value, okay, so what happens here? I'm going to use a package called as label encoder. I'm going to use a package called as label encoder. Okay, that comes in scikit-learn. Okay, that comes in scikit-learn. So here that is one of the pre-processing technique. So from the pre-processing sklearn, from this package of pre-processing, I'm importing label encoder. I'm importing label encoder. So when you take this label encoder, I've got all these categorical columns, and first I am importing it and then I'm instantiating it. Okay, LE is equal to label encoder of, I'm calling the function, I'm instantiating it, and using the instance, using the LE object, I'm going to use this function called LE.fit transform of. If you see now here, after I fit transform, you remember I removed the columns in DF, okay, and now it is all in DF1. And can you see here what are the columns? Hypertension is all zeros and ones. Diabetes mellitus became zeros and ones, yes and no. Can you see here? Before which it was yes and no.
Yes, ma'am.
Okay, so now my data set is not having any missing values. My data set is not having any what do I say, missing values. My data set is not having any categorical values now, and now I'm very much sure I can start developing my machine learning model. All right, can you all try this now from sklearn? Suppose if you have closed and opened your Colab, I want you all to restart and run, click on runtime and run the cells, because it's Python is interpreted language. All right, Python is an interpreted language, and once you close it off, the binding of variables will be lost and you need to rerun it again. Okay. Now convert these categorical columns into numerical columns. Now then we are fit to move on into a developing of a machine learning algorithm. Yes, once you are done, let me know your answers on chat. Yes, any doubts you can also ask me.
Trying, ma'am.
Okay. If you are not going to try it out, then you will not be able to know is it right, wrong, and how far you are doing it. I strongly encourage everyone to try it out. And this would be the best takeaway of all these efforts taken in conducting this program. A certificate is not going to value you. The concept, how much it's transferred, and how far you've experienced it is the greatest asset. It's not the feedback, it's not the certificate, but how far you have learned something new. How many of you are using mobiles? Type M on the chat. If you're using laptops of PC, L for laptop, P for PC. Can you quickly give the response on the chat, please? Yes, thank you, Sarada ma'am. It's laptop. Others? Only one response out of 23. Using both. Okay, Deepa ma'am, Saranya ma'am, yes. Got an error. Try to check it out. Are the others trying?
Ma'am is saying that cat calls are not defined.
You have to run it from the first. Once you have closed it, you need to run it from the first.
Okay, ma'am.
Okay, I'm
Okay,
getting
ma'am.
response from Cornelius Joshua. Okay, thank you. Most of you are very silent. You don't want to interact. Feel free to interact. You get an error or you get an answer, put it onto the chat. If you are using laptops, put L on the chat. Mobiles, put M on the chat. Or PCs, put P on the chat. Waiting for your answers. Only 3 responses, 3 or 4 responses I've received. That will enable me to understand how far you are connected with this session. Okay, Shanti ma'am, laptop, Pangavaja ma'am, again mobile. Okay. Okay, others? Others, please, quick. Yes, how many of you have tried it? And after it is converted into, all are converted into categorical to numerical formats, right? Once it is all converted, now we are ready to start off with the machine learning algorithm. So how many features we have? 25 features. So we are going to split the features into data set into features and target. Remember, yesterday we were seeing about features and target. We need to split the data sets into features, m columns and n rows, and m we are going to split into features and target. Okay, and how many features, how many target we have? How many features and how many target we have? Okay, if I'm going
So
to,
target have a classification.
yeah. So from age, blood group, specificity, here everything comes under X dot. If I come df1 dot columns, okay, if I give df1 dot columns, I get all my columns here. So these are my columns which carries my feature and target. So now first step, what I'm going to do, I'm going to split my entire data set into features and target. Okay, I'm going to split my data set into features and target. Now listen carefully. Okay, then only you'll be able to understand if you are new to machine learning algorithm, how does the algorithm comes and how does the algorithm works into. All right. So first we have to split the data sets into features and target. Okay. So I have my data set. What is CKD? Okay. What is CKD? Can one of you say, please? Yes. You're all responding or you don't want to respond? Okay.
CKD might be
I'm going to split
0
it.
at 1 month.
Yeah. My target is, what is my target? That's my class. Okay. So I have my data set.
Classification.
Okay. This is my data set. I'm going to split my data sets. All right. Into two. Can you see my Jamboard? Can you see my Jamboard? Hello?
Yes, ma'am.
Yeah. Okay. So into features and targets. So how many features I have? So these are my column names. Okay, these are my column names, right? These are so many columns that I have. Okay. These are my features. So what I'm going to do, these are my features that I've taken. So many features, and what will be my target? My target will be my class. What will be my target? My target will be my class. Able to understand? So these are the features, these are the target. So these features I'm going to name it as, see, I'm going to name it as X. Okay, and the target I'm going to take it as Y. Okay, this I'm going to name it as X, and this I'm going to, so furthermore in my program, whenever it is X, it denotes the features, and Y, it denotes the target. And in class, what are the different outputs I have? In class, what are the different outputs I have? What are the variables in class?
0 or 1 month.
Okay, very good.
0 or 1.
Okay, what is 0? 0 specifies the patient has got a disease, which is CKD. If it is 1, it specifies
No disease.
it specifies no kidney disease. Okay, I'm going to keep it as ND. All right, so these are the features, these are the target. So I'm going to split my data set into X and Y. So how am I going to do it, right? So here, and before which you have to keep your data set correct, right? So I'm going to make it as df1 dot drop off. Okay, df1 contains all my data set without any missing values, and also everything is label encoded. Okay, everything is numerical. Now I'm fit to start developing my machine learning model, right? So I'm going to df1 dot drop. I'm just dropping only my class. Y axis is equal to 1. Can any one of you say y axis is equal to 1? Because I want to drop the entire column. You remember, whenever axis is equal to 1, it specifies the column, right? So I'm making axis is equal to 1. So X will contain 24 columns and 158 rows. All right. And then Y. So Y, I'm going to assign only my column df1 of class to Y. All right. Now X contains all my features and Y contains my target. Can you all try it now? After you dropped, I know, I suppose you should have all dropped. df1 is equal to df dot drop of, okay, drop na of, comma, okay, drop na of. So you have removed all the rows that contains missing values, and then we have started working with a df1 dot drop the class, so you get all the features on x and y. Is it clear till now? Can you all try this x and y? Can you all try x and y now?
Okay, ma'am.
Yeah. Once you have dropped x, and your class should contain only two variables, CKD or non-CKD, either zeros or ones. Once you have done, you can post it onto the chat that you have done. Okay. I hope you should have got an X. Let's be quick. Some of you are not responding. Kindly do respond.
Getting an error, ma'am.
Have you given apostrophe? Have you opened the bracket and given a square parenthesis? And class and comma axis equal to 1.
Yes, ma'am.
And y is equal to df1 dot class. And also for the others, we have allotted the Google, so not Google, Python notebook. Kindly upload it. 30 of you have joined, and only one Suruchi ma'am is uploaded. I wish all to upload. Others are trying. You have not defined df1, ma'am. You have to give before which, give df1 is equal to df dot drop na of. df dot drop na open and close parenthesis, then you can start working. Without that, it will not run.
Okay, ma'am.
Okay. So now you have understood, and y is equal to very simple df1 of class. Only the class column we are assigning it to y. So y contains like zeros and ones. X there is no null value. Y also there is no null value. Okay, but X contains so many columns and Y contains only class, and this class should not be there onto your X. Okay, the target should not be there onto your features. Okay, hope you should have completed this. Y is equal to df1 dot class, and X is equal to df1 dot drop of class, which is axis is equal to 1, where axis is equal to 1. Okay. So after you complete splitting into X and Y, okay, the next step what we are going to do, now listen very, very carefully. We are going to take our data set and split them into training data and testing data. Okay, so using my training data, I'll be able to develop my machine learning algorithm. Okay, for testing my data, I will give only my feature. With the data that is learned by the machine learning algorithm, it will give me a predicted output. With the predicted output, I'm going to find whether I have my original output and the predicted output, then I'll be comparing the accuracy between the both. I repeat it, listen carefully, listen very carefully right now. Okay, so I'm going to split using another package called sklearn.model underscore selection, import train test split. Okay, so I'm going to split my entire data set X and Y into a training data and testing data. So if I split X into train and test and Y into train and test, I get so 4 things, right? X train, X test, Y train and Y test. So with this training data, I'm going to use a machine learning algorithm to try to develop it. Okay, try to develop it, right? To train using a machine learning algorithm, right? Post which I'm going to test it only with the features, only with the Y train, okay, only with the X test, okay, only with the X test, and from which it is going to find out, okay, which is going to find out, that will give me a result, and I'm going to check that with my predicted result, with my actual result, wherein I can able to find the accuracy of my data set. Okay, accuracy of my data set. Able to understand? Now listen. Now how is the data being split into? Okay, we have our data set. So the data set, we have split them into how? X and Y. You remember? X and Y. Okay, and each I'm going to split them into training and testing. Okay, so here I will have all my features. I will have X train. Okay, X train, and here what I will have?
X test.
Very good, X test. And then in my Y, what will I have? Again,
Y train and Y train.
Y train and Y test. What it will be there on my train and what it will be there on, sorry, what it will be there on my X and what it will be there on my Y?
X are features and Y is the classification.
Yeah, Y is my target. Y is my, sorry,
Target.
Y is my target. Y is my target. So Y test. Okay. So I'm going to develop a machine learning algorithm. All right. I'm going to use a machine learning. So I'm going to split my data set into train and test. X contains my features and Y contains my target. Okay. It will have only zeros and ones. Y train and Y test will contain only zeros and ones. And here I have 24 columns. All the 24 columns will be there on my X train and X test. So how am I going to split it out, right? How am I going to split it out? Using this package, okay, using this package called as X train sk learn.model selection import train test split. Okay, import train test split. I'm going to use this function train test split to, what is input I'm giving? X and Y. And you remember, see here something, it is called as test size 0.3. So what will happen if I'm going to give my, say for example, if I'm going to give my test size, okay, test size, okay, I can type it as test size, which is equal to 0.3 means it will take, okay, it will take 70% of data for training, okay, and 30% data for testing, 30% data for testing. Okay, my entire data set, it will automatically split into training and testing. Okay, I'm going to have, say for example, okay, if I'm going to have my test size as 0.2, then I will take 80% for training and 20% of the data for testing. Able to understand? Say for example, if I'm going to have my test size is 0.4, Can one of you say how much data will be taken for training? How much data will be taken for testing? Can one of you say? Can one of you say?
Ma'am, 40% for testing, 40% for testing, and 60% for training.
Well said, correctly said. Okay. So, but there are different ways each of the researchers they do, right? But for me, I predominantly use 0.3. I always use 0.3. So 70% of data I will be taking it for my training set, and 30% I'll be using it for my testing set. But this can be done automatically. And one thing you want to understand, what row is there for my X train, okay, will be the same on my Y train. It is done automatically. Sometimes you see, how ma'am, how it will split, how it will get coordinated between both. Okay, now you are able to understand the test size. Okay, 0.3, 70% for training, 30% for testing, 0.2, 80% for training, 20% for testing. If the test size is 0.4, 60% for training and 40% for testing. So, and then I'm going to take it from my random states. Are you able to understand still now? Yes. I have my data set, I'm splitting into features and target, and each of my features I'm going to train at my X train and
Yes, ma'am.
X train and my X test, and then my target Y I'm going to take it to my Y train and Y test. All right. So now if I'm going to print the shape of this, okay, if I'm going to print how far from the entire data set it has been split, I told you, right? It's dot shape dot shape dot shape. If you're getting any doubts, feel free to unmute and ask. All right. Okay. See here. After so totally, if you add 110 plus 14 plus 48, what you will get? Okay, X train, X test, Y train, Y test. Can you see the X train and Y train contains the same number of rows, 110 and 110, and X test and Y test contains the same number of rows, 48 and 48. All right. Say for example, if I'm going to change this to 40, okay, which means 60% for training, 40%. You check it's 110 and 48. It will change now. See 94 and 64. It is done automatically using this package. If I'm going to use 0.2, okay, 0.2 or something, whatever I give, 80% will be taken for training and 20% it will be taken for testing. Are able to find the difference, how the test size changes and the size of X train and Y train, X test and Y test changes? You're able to follow answers on chat. Why? If you're not able to follow, put on the chat no. Quick, I want everybody to give a quick answer, please. Able to understand the concept? Hello? Yes, thank you, Deepa ma'am. Deepa ma'am, Suruchi ma'am, Saranya ma'am, Deep. Others? Panjavarnam ma'am. What about others? Okay. Okay. I don't know how many of you are really connected. Okay. And here, if you see X train, Y train, X test, and Y test. Okay. Now I'm going to take it to be a 0.3. All right. And see, you can understand now. I'm going to print. Okay. I'm going to print. Because whatever it is, okay, it will take the same rows on your features and its associated row on the target. Okay, so I'm going to do like X dot train off and Y dot train off. That works. See, can you see what is my row number here? 269. Can you see the first row 269 for all my features? And also, can you see the same row number on my target? So X train and Y train will be the same. What is the feature? What is the associated target for the particular row will be reflected. Can you see here? 269, 11, 389, 250, 397. It's the same on the target. I've just shown head. On my X train, what I'm printing? X train and my Y train. So you need not think that how it is automatic to split, whether the features should be the same associated target. Yes, it is the same. All these are defined in this function, train test split function, that comes under escape learn model selection. Okay, and next the same thing I'm going to show it to you on X test and Y test. Okay, see here it is 48. What is there in your train will not be there on your test. So 48, 251, 271. Okay, 48, 251, 271. Same thing, 48, 251, 351, 271. Okay. Are able to understand the end? Even if I work with even 20 lakhs of data, 50 lakhs of data, it will automatically split it. So this is the functionality of train, test, and split. Whatever data you give for your X train, it will be associated with your Y train. For X test, what is your row value? The same thing will be your Y test. Okay, any doubts till now? Any doubts till now? Okay, can you all try splitting your data set into X train and Y train? But Y should contain only zeros and ones, and X also should contain the different features. There should be no missing values. Okay, and there should be, or everything should be label encoded, and then only it works. Okay, can you all quickly try? Yes, please. Once you got doubts, also post it on chat. Once you have done, post it onto the chat as done. Waiting for you. Kindly, any doubts, post it onto the chat. Yes, waiting for your answers. Yes, have you all split it out?
Doing, ma'am.
Yeah, thank you, ma'am. All right. Others also feel free to unmute and ask questions. If you're not trying it out, any theoretical concepts, understanding questions you have, kindly let me know.
Got an
Okay, ma'am. So it should be, your y should contain only two values, okay, zeros and ones, and it should be all into my categorical values, right? And then after I split it out, okay, now you are able to understand how have I split my data sets into x and y into 70. Now you understood what is x train, okay, the features. These are also the y train features. X test, y train and y test. This will contain zeros and one. This will contain zeros and one. And the rows of these will be the same. X train and y train, the rows will be the same. And X test and y test, the rows will be the same rows. All right. That is what we have seen in using head of function, right? And now we are going to do, there are different classification algorithm. I'm going to take this algorithm called as sklearn.ensembler import random forest classifier. So random forest is a classification. There are many like Gaussian A-base is there, all right. And then you have got linear SVC, random forest classifier, decision tree classifier. There are multiple classification algorithms available. There are multiple classification algorithms available. So from sklearn.ensemble import random forest classifier. So from sklearn.metrics, I'm going to import accuracy score. How far is my accuracy? Okay. So here when you come into it, I'm going to have a machine learning algorithm. It could be any algorithm. For what is algorithm I've taken here? Random forest classifier. Okay. For example, I've taken random forest classifier here. Okay. So I'm going to have this algorithm. And in this algorithm, I'm going to use, okay, I'm going to train this algorithm using my, if these are my features, okay, and this is my target, and this is my target. So these two are given as input values. What are the things given as input values? The features and its associated target. And the output it will give me, it will have my learned patterns. What it will have? It will have the learned patterns. So if my features are like this, okay, how far I get my target. If the student gets mark like this, whether he'll pass or fail. So the learned patterns are there kept here at the end of the algorithm. Okay, at the end of this algorithm, the learned patterns are kept. Okay, so listen carefully. Now I'm going to use, I'm defining and instantiating random forest using entropy. What are the maximum features? Auto, because it's going to be a forest, the minimum leaf sample, the split and estimators. What are the associated values to instantiate it? It's all given over here. All right, and RD underscore CLP, where I have done, I'm instantiating, I've instantiated it, and then I'm using my X train and Y train. What I'm using? I'm using my X train and my Y train. Okay, what X train will contain my features, Y train will contain my associates, because here it fits into the number of decision tree. That's what, how many levels of the tree, what are the depths of the tree, all are given. So these two are given, and the learned patterns are all residing into this, and the learned patterns are all residing in this, right? So after I have the learned patterns over there, okay, after I have the learned patterns, I'm going to predict my algorithm. Can you see here? I'm going to predict my algorithm using, okay, RD underscore CLF dot predict of, okay, I'm going to predict using only my testing value. What is my testing value? Which contains only my features, okay, which contains only my features. RD underscore CLF dot predict of only my features, X test, okay, X test. So it will give me my predicted output. What is my original output for my X test? It will be my Y test. The X test and its associated values will be, it will be in Y test. You remember X test, the associated values. So I'm going to do my testing to the learned patterns to my X test alone, to the output of this algorithm. And what output this learned pattern is going to give me is called as my predicted result. It is my predicted output. Okay, it is my predicted output. Okay, so only I'm going to give my features. Listen carefully, I'm going to give only my features, and this is going to give me my target. What is my original actual output? This is my actual output. Y test is my actual output. I have not given any. Yeah, Y test is my actual output. So I'm going to compare my X test with my Y test. So I will be comparing my X test with my Y test. That if it is everything, the actual and the predicted is the same, then I get 100%. Then I get 100% accuracy. All right. Then I get 100% accuracy. If the values are not changed, then the percentage decreases. So I repeat it. I take my data set. I'm going to split, listen carefully, into features and target. Features contains all my 24 features and target contains only one target, CKD or non-CKD. I'm going to split using train test split function, X train and X test. This contains my features, and Y train and Y test contains my target. Okay, the X train and its associated target is there on my Y train. X test and my associated result is on my Y test. So I'm going to use an algorithm where I'm going to feed only my, if this is the feature, what will be a target. So with this machine learning algorithm, what it does, it learns the data patterns. If my patterns of data are like this, then this person is a kidney patient. If my data patterns are like this, then he is a not non-CKD patient. All right. So that has been done. And then with the learned patterns, I'm going to give an input, right? The predicted function, I'm going to input only my feature, not my target. Only my feature, because it has learned the pattern and kept it on the object. Okay, once I give it over here, learned patterns, then I get my predicted output. Where do I have my actual output? Y test. You see, I have not used Y test anywhere else. So I'm going to compare my Y test with my predicted test. That defines my accuracy. Okay, that defines my accuracy. Okay, so here I'm giving accuracy score Y test, where it contains my actual result, RDCLF of X test. Okay, that is my predicted output. Both I'm going to find it out. What is my accuracy here? I'm getting 1. Okay, I'm getting 100% accuracy in this data set. Okay, and then we are computing a confusion matrix. So for confusion matrix, it is, I'm going, I can do one thing. I'll do like predict is equal to, what is my predicted output? Because I fit over there, I'm going to give it like pred is equal, and wherever it is, I'm going to give pred as an output. That will be a little easy for you to understand than giving the function. Okay. Each time it also changes. Okay. Hash is a command statement. Okay, see, it has tested accurately. So I've got 100% accuracy. Everything is perfect here. But generally we don't get like this. Okay, generally we don't get like this. Okay, we'll go into one algorithm, and then again we will be discussing more about classification report and the confusion matrix. Okay, and the confusion matrix. Like, let's try with Gaussian naive-Bayes algorithm and let's see how it works. Okay, I'll just show you an example. So if I want to use another algorithm, okay, from sklearn dot naive, it's naive based algorithm. From naive base, I'm going to import one algorithm that we're going to work today, which is called as a Gaussian naive base, which is called as it's Gaussian naive base. All right. So NB. And I will say this is the algorithm that I'm going to use. Okay, Gaussian naive base. So once I import Gaussian naive base algorithm from my repository of scale naive base, I'm going to instantiate it. GNB is equal to, this is a user defined variable. You can give any variable that you wish, and I'm going to instantiate it because Gaussian naive base, it's simple. You don't have so many parameters as random forest classifier. And then what I'm going to do, and I'm going to do the same thing here, how I have done it, right? How I have done it, right? So I'm going to fit, I'm going to predict, and I'm to find the accuracy. So what is my object here? It is not RDF, here it is JNP. So you remember, we'll be fitting using my X train and my Y train. So X train and my Y train, I'm be fitting it, and for my predicting, I'll be using my Y test and my output. Okay. So for predict, what I'm going to do, GNP dot, what is my predicted output? I'm going to feed in only my X test. Okay. For my training, okay, for my training to learn my data patterns, I'll give X train and Y train. To predict my output, so for prediction, for my testing, I'll give only my features. Using this predict function, my data set, it will find it out what will be my predicted output. So I am going to use spread one because I use spread over there. Okay, and then what would be my accuracy? Okay, GNB underscore accuracy. Okay, I'm going to check with my Y test is the same and my pred, and let me print the accuracy and find it out. How far is my accuracy better in comparison? JNB underscore AAC. Let's see. Oh, for this also I'm getting 100% accuracy. Okay. So this should not contain your target. Okay, X train will not contain your target. It will contain only your features. Okay, can you see age, blood pressure? It doesn't contain your, it doesn't contain any of it. And Y train, it contains only my target. And still my accuracy, I'm getting it as 100%. Okay. Okay, can you all try this algorithm now? Can you all try this Gaussian naive base? It's simple. Are you able to understand? We are learning, for learning patterns, we are using the train. If my patterns of data are like this, and what would be my target? After it has been fit, I'm going to predict it with my new data set. Okay, X test. And then I'm going to use spread one of. All right, I'm going to compare my pred one result with my Y test, and my accuracy, I'm getting it as 1%. I want you all to try. I'll wait. And before which you have got any doubts during the session, kindly do ask. Yes, please.
Trying, ma'am.
Okay, okay, ma'am. Okay, the recordings will be shared, ma'am, so you can follow it, Suruchi, ma'am. Okay.
Yes, ma'am.
And there we have given step by step of it. What about others? I'm getting response only from Deepa ma'am and Suruchi ma'am. What about others? How many of you connected now? Answers on chat, please. Yes, thank you, Ramya Lakshmi. Yeah, thank you, Shanti, ma'am. You keep responding that you're trying. I don't know how many of you are silent listeners or silently walking without letting it out. Yeah, ma'am, you missed some parts, right? Try to understand the concept, post which you'll be able to try it out after the session once the recording is shared with you. You are trying it? Others, any doubts, any questions regarding till what we have done? Tomorrow during the end of the session, we'll play a live quiz. So let's see how many of you are going to participate and how many of you are going to win. All right. Thank you, sir. Thank you, Cornelius. Those are trying and those have completed, maybe at the end of the day, I wish you all to upload onto this assignment given onto this Google Classroom. Okay. If you are not, because it contains the data set. Okay. And again, I'm sharing the classroom invite link to all. Kindly do join. I wish the participants to be even more energetic. Only 3 responses I get from Deepa ma'am, and then from Suruchi ma'am, and from Shanti ma'am. And also Cornelius sir, Cornelius, 4 responses. Thank you, Panjavarnam ma'am. I know you're using mobile, maybe after which you'll be able to try it out. Otherwise, it will be like how you see in YouTube, right? The recipes turns out to be so good, but only when we try, we really know how that recipe is going to come. So same thing happens in data science. You listening to it, seeing the demonstration, it looked really wonderful. But only when you put your hands together on it and only when you work, only you will be able to know it. Yeah, thank you, Panjavatnam ma'am. Okay. Yeah, you need to practice a lot. Okay. Now we move on to the next concept called as confusion matrix. Okay. So how far you're going to import a confusion matrix? A very simple method is um, uh, I can show for J and B itself. Okay, how many true positives and how many true negatives we get, right? So here my output is spread 1. Okay, I'm passing this functionality called confusion matrix, my original result and my predicted result. Okay, I get something like this. Okay, can you see one? It's a 2 cross 2 matrix. It's a 2 cross 2 matrix. Okay, so what are the true positives and what are the true negatives? Okay, the true positives and the true negatives will be checked over here on the confusion matrix. Then we move on into a classification report. Okay, say for example, move on to the next page. I'll try to take a sample from Google image search. Confusion matrix. Okay. So this is what the confusion matrix, the actual and the predicted. Okay, or the predicted and the actual. So for say for example, if I'm going to take how far was my original, how far was my predicted. Okay. Okay, this looks little confusing. I'll try to take this. Okay. That's a 2 cross 2. Okay. If in my actual data set is also positive and my predicted is positive, then it is called true positive. Okay. In my actual, what is my actual? Y test is also positive 13 and my predicted is also positive 13. This 13 is called as true positive. Okay, in my actual also they have got they have a disease and here also it is positive, so it is true positive. So always when you think these diagonal should be 0 or always it cannot be 0. Say for example for some data set it will be like 1 or 2 or something relatively less. If your accuracy is less, then this diagonal will have more value. Since here we have got an accuracy of 100%, since here we have got an accuracy of 100%, it works like this, right? And this what is 13 is called as true positive. My actual data set also is positive. Y test is also positive. In my algorithm, what it has learned and it has got an output, right? That is also positive. That is also positive. Okay, I'm giving my X test, I'm giving my predicted output, I have my test Y test also. So this is called true positive. 13 stands for true positive. Actual data set also is negative. Okay, it's a negative. And my predicted data set is also negative. So it is true negative. This diagonal should be more and this diagonal should be less. Able to understand the concept of true positive and true negative? In my actual data set is also positive, my predicted is also positive, that is true positive. My actual data set is also negative, my predicted data set also. This is what I desire to be. This is what I desire to be. So this is called as true positive and true negative. Able to understand true positive and true negative? Answers on quickly on chat, yes, no, at least Y or N. Able to understand true positive?
Yes, ma'am.
Yeah, thank you. True positive and true negative. Now listen carefully. Listen carefully. We are moving on to the next one. Actually, it is negative. In my Y test, my value is negative, but my predicted it is showing positive. So it is called as false positive. Okay, it is predicted as positive. Actually, it is negative. Falsely, it is predicting as positive. So this is called false positive. But in my case, I don't have anything as false positive. I don't have anything as false positive. So true positive, true negative, this is false positive. Actually, it is positive, but it is predicting as negative. So it is false negative. So it's false positive and false negative, true positive and true negative. So this is what is called as your confusion matrix. This is one of the important metrics on machine learning algorithm. It's one of the important metrics of your machine learning algorithm. Able to understand? Two of you have given the response. What about others? Okay. Okay. Able to understand? True positive and true negative. And also you can try for different visualization. Okay. From there is a package called yellow brick classifier. Okay. The same thing, but you can have a good visualization if you're writing for journal papers. And import, I'm going to import the confusion matrix. Okay. Okay, what is the model I'm going to use here? It is GNB. Okay, confusion matrix for GNB is equal to, I've imported the function, right? Confusion matrix, sorry. A confusion matrix is the function. What is the parameter I'll use? I'll use the instantiation. What I've instantiated for JNB is JNB, comma. What are the classes I have? I have zeros and ones. Zero means they have a disease and one means they don't have a disease. All right. So I'm declaring a variable and instantiating confusion matrix. How many class? If you're going to use multi-class, then you should use multi-class. Then cm underscore jnd dot fit. How do I fit x train and y train? All right, and then cm underscore gnb dot score. What would be my score? My x test and my y test. Okay, and then I give cm underscore gnb dot poof is to show my classification report. Let's see whether it works. Yeah. Can you see the same classification with the visualization? So this is a true class, this is a predicted class. Truly positive, predicted also positive. Okay, truly positive, predicted also positive. Truly negative, predicted is also negative. So this diagram, can you see here the predicted class and the true class? This is the JNB confusion map. Same thing I can do it for the first algorithm I've done, right? For the first algorithm I've done. You remember for random forest classifier? I'm getting a confusion matrix like this if you want to use it for journals or and what is what is my parameter? What is my object? It is RD underscore CLF. Instead of JNB, I have to use RD underscore CLF because that is the function, and here I'll be using a random forest RF. This anything user defined. This is a confusion matrix for RF. So I'm going to give it as RF. Now if I see Okay, I've given a close parenthesis extra. Can you see? I don't know, the both algorithm gives, let me try with linear SVCE. Okay, linear SVC, whether I'm, for that also, I don't know whether I'm going to get, are you able to understand how for different algorithm it works? Is any doubt still now? Okay. And then we move on into our classification report, and then we move on into a classification report, right? So we have tried two algorithms, and I'm moving on to the third algorithm now. So for this, yeah, no doubts. Thank you. Once you understand the concept, only it will be easy for you. I'm going to use a support vector machine, and that is what I'm going to import SVM, and I'm going to import linear SVC support vector classifier. I'm going to instantiate using a linear SVC random underscore state. I'm not going to give, I can give 10 or something. Here I'm going to give it as SVC. I'm just showing a different demonstration of algorithms so that you'll try to understand it. So wherever I used, and it overrides, so I'm rechanging the predicted value, and here let me see what accuracy I get for SVC. So from import, I'm instant. I can give it 0 or I can give it 10 also. I'm going to predict it. Let's see. Yeah, can you see here? I'm getting 0.875 as my accuracy. It's not 100% accuracy. Now we'll try to understand when I put my confusion matrix. Okay. I don't know, for the past two algorithms, we got it as the same. Now you've got 80. Can you show the code, as I cannot run further? Yeah, I will show, ma'am. Just 1 minute. I'll show this demonstration. Okay, here I'm going to use, what is my function here? SVC. So the confusion matrix for SVC, 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 and SVC. Okay. Can you see it's true positive, 7 are true positive, and true negative. This is false positive, okay, and false negative. False positive, it has shown 1. It's false positive, and this is false negative. Can you see 6 of the things have been predicted wrongly? That is what the accuracy has become 87.5. Both algorithms, whatever we tried, we got 100%, but here we are getting 87 because 6 predictions were wrong. Okay, I will show to you, Suruchi ma'am, how do you split my train and test? You wanted to do that? Yeah, you can take it out. I'll give time. And then we move on into our classification report. Others, any doubts, can you please ask me? Or the theory, if you're not working even in the theoretical part, if you have got doubts, kindly let me know.
No, ma'am.
Thank you.
No doubts, ma'am.
Thank you, Deepa ma'am. And Suruchi ma'am, you can try doing it. Okay, once you have done, post it onto the chat. And also some of you, if you have joined little late, we started with how do you split our training and testing. After curating my missing numbers after we curated the missing numbers and converted all categorical values into numerical values, then we moved on into train test split. If you have done, you can tell me. Others, are you trying or able to follow? Only from Deepa ma'am and few ma'ams and one sir I'm getting response. What about others? We have Soundarya ma'am, Satish ma'am, Abhirami ma'am, Gomati ma'am, Manigandan sir, Harini ma'am, Nesa Kumaran. Can you give a response and chat? Once you have completed, let me know, ma'am. Then we have got three metrics to see: F1 score, precision, and recall. Okay. This is how we have split y is equal to df1 of class and x is equal to df1 dot drop of class of x. Okay. Okay. Next, we will move on into a classification report. So, you were able to understand about confusion matrix? Yes. So, true positive, true negative, false,
Yes, ma'am.
false positive, and false negative. Okay, false positive and false. Now, the next matrix that we are going to go is called as a classification report. Okay, the classification report has got classification report. I hope my screen is seen what I'm typing. Classification report. Yes, can one of you unmute and say? I'm using it on Jamboard. You're able to see it?
Yes, ma'am.
Okay. So classification report. It contains three parameters. What are the three parameters? F1 score, precision, and recall. Okay. F1 score, precision, F1 score, precision, and recall. And each has got its own formula. Each has got its own formula. So how it is being evaluated? Okay. How far you're going to take a classification report? Now you understood the values of true positives and true negatives. Okay. True positives and true negatives. So classification report. That search didn't get me the correct one. Okay, so these contains three metrics: F1 score, precision, and recall. And these are some of the major important metrics that you need to find it out. Okay, we need to work it out. And what are the formulas associated with that? Okay, what are the formulas associated with that? So what are the three things I told? Precision, recall, and F1 score. Precision, recall or sensitivity also they could say, and the F1 score. Okay. This is the formula for it. Okay. Can one of you say what is TP, FP? Can one of you say what could be TP? What could be FP?
Ma'am, target for TP, FP for features.
No, TP stands for true positive and
Acha.
FP stands for true negative. Okay.
True negative. Okay, okay.
Okay. So accuracy, if I want to find how much of how do you find the formula? Okay. How many true positive, how many true negative divided by total number of data set. True positive plus true negative divided by true positive plus true negative plus false positive plus false negative. You all understood, right? True positive and true negative. And same
Yes,
thing
ma'am.
happens here. So if I take an accuracy formula, TP, true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. All right. All these computes my accuracy. So when I'm going to compute my classification report, okay, I'll just show you my classification report. For the first one I've done. Okay, this is a program, the simple coding for the classification report. Not the entire one, only this line. Okay, y test and my predictor. What I'm getting, can you see here? Precision, recall, and F1 score and support. Okay, so here, if I'm going to try the same thing for Gaussian naive Bayes, okay, I have not tried it for Gaussian naive Bayes, and also it is also going to be the same. But I can show you a difference only on linear SVC, where we have got some values less over there. I'll show you the demo for both Gaussian naive Bayes and linear SVC. Only you need to change, yeah, it's spread 1, right? It's spread 1 we had for Gaussian naive Bayes. Here also it is 1 because we had accuracy 1. Now it is spread 2 for linear SVC, where we got 86%. Can you see the value little changes? Okay, there was false positive, false positive. Okay, false positive were there. So that is what in one I'm getting. Since it is false positive, here I'm getting little less value. In precision, you can see the value is less in 1, and in recall it's the opposite, and F1 score is like that. So jumping into the formula, precision is how much true positive divided by true positive or false positive. How much only the positive factors only comes in precision. Can you see? True positive divided by true positive plus false positive is my precision value. Able to understand my precision formula? When you take recall, true positive divided by true positive plus true negative. So only the trueness of the value is taken in recall. True positive divided by true positive plus true negative is the formula for recall. For precision, it is true positive divided by true positive plus false positive. When I take F1, how the F1 score is computed? 2 multiplied by precision into recall divided by precision plus recall. Okay, precision into multiplied by recall divided by precision plus recall. If you want to make, if you are taking notes or if you are making a note of it, kindly make a note of these formulas: accuracy, precision, recall, which 5 metrics we have seen: accuracy, precision, recall, if and score, and confusion matrix. There are more than 12 metrics, but we will not be able to discuss everything. But these are the 5 metrics we are seeing for the session. Tomorrow we will start with image database, images. I wish everybody to use your laptops for tomorrow's session. That will be my final session. But when you are a research scholar and you want to do, you cannot use this algorithm as such for your presentations. For a research contribution, you have to do a fine tuning. You have to have a novelty on the algorithm, maybe on the algorithm that I'm using it, or the way you do a feature engineering. How are you going to select the features there? You can have your own optimization algorithms. All right, where and where that you need to work on with that. Okay. Now, when you see the classification report, this function is classification report, y-test, comma, pred1, pred2, pred1 and pred2, because I've used 2 algorithms, 3 algorithms I've given like this. This is the accuracy here, 88% is the accuracy. And same way you have got visualization also for it. Any doubts till now? Those of trying, kindly try it out. Okay, so today's afternoon session we started with the data set with label encoding. After it is curated and the missing values are dropped, we split the data set into X and Y, and that features and target have been split into training and testing set. For developing or training learning patterns from the data, I'll be using a machine learning algorithm where I use my X train and my Y train. It learns the patterns. Then for the predicting model, I'm giving my Y train, I'm giving my X test and it predicts the model, and I have my original target, that is Y test. I compare both and find the accuracy. Fortunately for us, for 2 algorithms, we've got 100% accuracy in Gaussian A-Bayes and also in random forest classifier, and only in linear SVC we got 88%. And then we moved on into the different metrics like confusion matrix, a simple confusion matrix, how much is true positive, true negative, false positive and false negative. Then we were seeing about yellow brick classifier, how the confusion matrix is seen on yellow brick classifier. That's a visualization tool. Same thing, we moved on to classification report. Okay, even in classification report also, we could have the yellow brick classifier. Okay, able to understand how have
Yes, ma'am.
how have we taken a data set, how have we visualized it, what are the things that we have seen, and then how far we have developed it. All right,
Ma'am. Yes, ma'am. No doubt. No doubt, ma'am.
thank you, Deepa ma'am. What about others? At least the concepts. All right, so before we come tomorrow, okay, I'll try to give you a classification, a disease data set. All right. And I want you to work it out and submit it. Thank you, ma'am. And I think the organizers will share the recording, and also you can find it out on my YouTube channel also.
Ma'am, kindly share the YouTube channel, ma'am.
Okay.
I need the recording actually.
Okay.
Okay, ma'am. Thank you.
And also every session of mine, I post it onto YouTube. In yesterday's session, you can just go into YouTube and search Doreen Robin, you will be getting it. And this is my channel, and you can also subscribe, and you find the session useful, you can comment on it. Almost all my sessions I host it onto, because all my subscribers, they always demand post your sessions, so post pitch also, they'd be able to find it out. See this, I'll share my channel so that you can find it out. All my videos will be there. Like yesterday's 2 sessions. This is the 4th session, and tomorrow we have the 5th and the 6th session. I've done it for the University of Madras. How do you analyze the social media analytics? How do you take data from Twitter and how do you analyze it? This is something on innovations. And I've given during this pandemic, we have trained more than 5,000 faculties around the world on e-learning tools. And for Satyabama University, during the start of this year, like I think January, I had given the entire talk, 5 series and talk of big data analytics about Pig, about Hadoop, the MapReduce, Pig, Hive, Tableau. All right, those functionalities will be there. The talk, it's a talk. Okay, it's a talk. It will be there. And then about deep learning. This is about, I went to a predictive healthcare analytics for a college, SA Engineering College. The students had live hands-on. If live hands-on, it's even more better. And some talks on artificial intelligence, cyber physical systems, AI, and cyber securities, AR, VR tools also. I should have demonstrated something onto that. And IPR tools, how it is used in businesses, like big data analytics and social, cyber forensics, cyber security, robotic process analysis, and virtual labs, right? So many talks will be there. Whenever you're an image processing, tomorrow we'll be seeing about image processing, and open CV talks also will be there. You can find it out. Okay, this is my channel. I hope it will be useful for you. So when you subscribe for it, kindly subscribe. So whenever I come online, you'll be able to get it. Yeah, from now coming on to this, I would like to give you one data set. See how many data sets you have got for just disease. Able to find it out? So this is thoracic surgery. After the patient is decided for a classification problem, all right, and post-operative, after operating of the lung cancer, right? If it is class is 1, their death died within 1 year after surgery. If the class is 2, they survive. Can you see? Okay, I want you all to take this data set and work on to that. Will you be able to work? 17 attributes, right? Diagnosis, okay, as multi-tumor or primary tumor, okay, and pain before surgery, and it is used if it is true or they died. If 1 year, if it is true, they have after 1 year they die, or if it is false, they survive. So 70 people survive and 400 people, they able to understand. You want to use this data set or you want some other data set? You can tell me. This is from Poland. This is the data contributed on 2013 from Poland. These are real data set. You see, that's what we always recommend you to use UCR machine learning repository. When you click on the data folder, you'll be getting the data set. Is it okay? Or you want some other data sets? This opening as ARFF. Or you want any other data set that you are going to work? This is another data set called diabetes data set. They don't know whether the particular patient has got diabetes or not. Or you want me to share some data set onto the Google Classroom. You want diabetes data sets, okay?
Yes, ma'am.
Yeah, I think I may have a diabetes data set on my system. Let me try.
Thank you, ma'am.
And share a diabetes data set with you on the Google Classroom. I worked on deep learning. I don't know. We don't have time. If I have time, I can show you how in deep learning it works. Let me try. Are able to understand till now what we have seen? Any doubts? I'm not rushing through, so that more importantly, you need to understand the concepts. Then you can change it for any kind of data set that you would wish to work on with.
No doubts, ma'am.
I use so many mail IDs. So this is the new mail ID I started using because all the mail IDs are full and my Google Drive is also full. So how do you find the session for the past 2 days? Can you give your views on the chat? You're able to understand, you're able to follow, not able to follow. Yes, please. Only a few people who keep responding, they're responding. I was heard that 70 people have registered. Thank you, Deepa ma'am. Thank you, Suruchi ma'am. I know your both names, but not others. I can just show you a demonstration of deep learning. The difference between machine learning and deep learning is that here you extract the feature, then you go on for classification. To understand in simple words, in deep learning, the classification and the feature, sorry, yeah, the classification and the feature selection goes hand on hand. Okay, you don't have a separate component as feature selection and then you go on for classification. Rather in machine learning, you need to do a class of feature selection, then move on for classification. Right? But there it goes hand on hand. There it goes hand on hand. My storage is full. And research scholars, I always recommend you to take at least 3 or 4 different data sets and a few algorithms. Then you compare it. First, do a research literature survey, try to find out insights from the data. All right, and then you'll be able to do. There are still more. There are many metrics. Something called log loss is there, a precision recall curve, AUC or OC curve. But because we don't have that much time, I will not be able to share those things with you. Maybe in the future, if you get connected, I'll be able to share it with you, right? You are asking, like Deepa ma'am was asking for, uh, yeah. Yeah. Any doubts you can ask me. You have my which part of it, because initially when you're starting to work, you may find it little some kind of confusing if you're not clear. Okay, feel free to contact me through WhatsApp or whatever it is. As and when I'm available, I'll be responding to you. And this is the diabetes data set. I'm going to show to you and you're going to tell me what will be the feature, what is not now the features, what will be my target. What will be the target for this? Quickly, let's see who's posting the first answer, correct answer on the chat. Will be the winner for today. I hope you're able to see my screen. It's getting loaded. Still, it is not loaded. Yes, pregnancy, glucose, blood pressure.
Outcome is the target.
Yeah, correct, correct.
Because it has good demands.
Yes, rightly said. You want me to share it on? I hope everybody you are into this Google Classroom.
Yes, ma'am, I need it actually.
Yeah, I'll post it on to that.
Thank you, ma'am.
From the and I want you all to work it out and let me know when tomorrow's class.
Yes.
And you can also post it onto the assignment given. This is diabetes.csp. Once you practice on a new data set, you'll be able to understand more about it. Okay. Diabetes data set. I hope all of you are in the Google Classroom or some of you are not there. If you wish, I can also share it on the chat right now. Those who are connected also can get it. So tomorrow we'll start with image analytics. Taking an image, what are the different morning session? I'll take the theory part of it. What are the images? What are the packages available in image? All right. And eventually we in the afternoon session we'll have the hands-on. I've shared it on the Zoom chat also. Have you all got it on the Zoom chat? Also the data set has been shared. Yes. So this is a benchmark. They say it as PIMA diabetes data set. So today, from yesterday and today, we have saw the different types of analytics that are available. And then in specific, we saw how to do a descriptive analytics. We have explored diagnostic analytics. Then we have started with a predictive model. Okay, once you have got all these data, if I'm going to maybe, I don't know if I have time tomorrow, I'll show you a web application for the same. For the new people, as you have got the testing, you can just enter the values of the thyroid data set, the kidney data set, and then you can have a predicted output. Okay, and your algorithm, if you are going to give those values, your algorithm, your web application will same. That is how it can be used in applications, right? That is how it can be used in applications. After you develop, after you propose your own algorithm, you can make it as a mobile application or web application. So before the person meets the doctor, they feed after the test, these are the values fed into it, whether I have disease or not. That could be used. It can be used for that sake. All right. And then we have seen how to split the data sets. What I'm going to ask you a question. What is the important measure to check before we develop a machine learning algorithm? I told two things are more important before we start a machine learning algorithm. We start training a machine learning algorithm. What are the two checklists?
Feature test, ma'am. Features test.
Your audio is not clear. Put the answers on chat. What are the two metrics or two checklists that you need to do before you start developing a machine learning algorithm? First, there should not be no missing values. Second, there should not be no missing values. Second, all your values should be converted, categorical values should be converted into numerical values. Only then you can start developing a machine learning algorithm. If you have a categorical value, then you will not be able to do it. Okay, first we have to take, yes, rightly said Shanti ma'am, at least more than 50 rows should be there. And then once it is you're ready for your machine learning algorithm, then we split the data set into training data set and testing data set. Then we train it with the features and the particular associated target. And then we predict it, we develop a prediction model from the patterns that is learned. We feed only our X test and it gives me predicted output. Then I compare my predicted output with my actual result, that is Y test, and find my accuracy. What are the metrics we have seen? Can one of you unmute and say what are the metrics that we have seen today?
Confusion matrix.
It's Cornelius, sir. I thought you unmuted it. Confusion
matrix, ma'am.
Yeah. Then classification report. In classification, what are the things we saw in classification report? Accuracy, F1, precision, and recall. So 5 metrics we have seen. Still there are more, 12 metrics are there, but maybe if you're interested, we can discuss more that in detail. All right. So I hope this session would have been, so we have started taking with text values and we have come across this. I've shared diabetes data set with you. Kindly work it out before you come for the next class tomorrow morning. Okay. Thank you all for joining. Over to the organizers.
Thank you, ma'am. Thank you so much. Thank you for the wonderful session today. And again, as ma'am said, I request all the participants to join with your laptop for tomorrow's session. Thank you, ma'am.
Welcome, ma'am. Thank you all. Bye-bye.
Thank you, ma'am.
Thank you, Karthik, sir.